Students, let's go over sections 1.1 and 1.2. Okay, key terms for statistics. Okay, what is statistics? Statistics is the study of data and variation. Okay, how we gather data and how it varies. Okay, data can be with regards to a sample or a population. Okay, a population is like a census, it's all of the data, and a sample is a sub-collection of the data. Okay, a parameter is a characteristic about the population, like how much is in the population, and a statistic is a measure of the sample, like how many items are in the sample. It's like a subset of the population. Okay, for example, a population, heights of every adult in the US, and parameter would be the average. The parameter would be the average height of every adult. Okay, a sample would be the heights of 500 randomly selected adults from the US, and a statistic would be the height of the average height of those 500 randomly selected adults. Okay, let's look at an example of election polling. We want to know what proportion of California will be voting for Mr. Lewis in the next election. We call 50 random numbers in California and ask, are you planning on voting for Lewis in the next election? Population is all voters in California. And the sample is the 50 random voters that we call. Parameter of interest is the percent of California voters supporting Mr. Lewis. And the statistic is the percent of voters supporting Lewis from our sample. Another example is medical testing. We use a machine to measure the amount of cholesterol, LDL, from a blood test. We want to find the average LDL of patients using a certain medication. We test 4 blood samples from 4 different people currently using the medication. Population, all people using the medication. The sample is the 4 people using the medication that we sample. The parameter of interest is the average LDL of all people on the medication. We would say that that's mu. It's a Greek U. Okay, mu equals some value. And the statistic would be the average of the 4 LDLs of our sample, or X bar equals. Example, a statistics student is interested in studying the study habits of math students at Santa Ana College. Out of all the math classes during the spring 2017 semester, the student randomly selects 25 students. And within these 25 sections, she randomly selects 10 students. After analyzing the result, what is the group of students that the study can be used to represent? And it's the spring 2017 math students. Okay, that's the population that we're analyzing. Okay. That's what we call the sampling frame. Okay, some types of data are categorical or categories, or qualitative we call it, and some are numerical or quantitative. Okay, so the ages in years of survey respondents, ages, is that qualitative or quantitative? That is a number. That is a quantitative amount, it's a quantity. The political party affiliations of survey respondents, that's categorical, okay, or qualitative. Social Security numbers, just because it's a number doesn't mean that it's a quantity, that it's a number, okay, that it's, you have to say, well, can I add, subtract, multiply, and divide these values? And if you can't, then it's a category. And Social Security numbers, you can't add them and get a new Social Security number. And so you can't divide them. You can't do arithmetic with them. So it's a category, it's categorical. Understanding percentages, 525 people take a survey, 65% of respondents claim they find statistics useful. How many people claim they find statistics useful? 65% of 525 is 341.25, so about 341 people, okay, in the survey of 525, and that could be a population or a sample. Okay. Let's look at this circle chart here. Vince divided the month's expenditures into 4 categories: rent, food, fun, and other. The amount she spent on the category are pictured here. Using the graph, approximate the percent of total spending devoted on food. Well, 244 over the total, okay, is a total. If you add those all together, you would get 1,100, and divide that by 244 by 1,100, you get 0.2218, which is about 22.2%. And if we eyeballed it, we'd say it's about 20%. Okay, studies of and types of studies and sampling methods. We have observational study. Okay, observational studies. Those are studies where we observe, okay, measure specific characteristics. We're outside the situation. We're just objective observers. Experiments, we're actually conducting the experiment, and we're inside the experiment. Okay, and we impose a treatment and observe the effects. This is a cause-effect relationship. Okay, type of study or experiment. Is an observational study or experiment. It is a study sponsored by Coca-Cola. 12,500 people were asked what contributes most to their happiness, and 77% of the respondents said that it was their family or partners. That is an observational study. Okay, we're not manipulating anything. We're just asking people a question. For part B, in a clinical trial of cholesterol, Lipitor, 100 of the cholesterol drug Lipitor, 188 subjects were given 20 milligram doses of the drug, and 3.7% of them experienced nausea. Is this an observational study or an experiment? It's an experiment because we are giving them something to produce a cause-effect relationship. See, I'm interested in seeing if running at least 1 mile a day could lead to reduced weight. I find that the average weight of 25 people who claim to run daily, and the average weight of 25 people who do not run daily. Those who claim to run daily have an average weight of 15 pounds less than those who don't run daily. Can I make a conclusion that running can reduce your weight? No, this is observational study. Okay, and how could I change the study to an experiment? I would select 50 people and make 25 run and make 25 not run. The 25 that are running are called my experimental group, and the 25 not running would be considered my control group. Okay, so control. And I would compare my control to my experimental group. Okay, what makes a good method of sampling? Okay, good method of sampling is a simple random sample. Okay, it has no bias in it. It's representative of the population that we're pulling from. Okay, we could have stratified sampling, cluster sampling, or systematic sampling, or convenient sampling. Convenient sampling is bad. Convenient sampling is like going into Walmart and asking people, do they like to shop at Walmart? Okay, that's convenient sampling, and there's a huge amount of bias involved in that. Okay, it'd be like going into Petco and asking if anybody likes cats. Well, you might get a higher percentage of people liking cats by walking into a pet store than people just randomly select it. Okay, simple random sample. Sample of n objects is selected in such a way that every possible sample of the size n has a same chance of being chosen. N, we represent m as the sample size. Okay, so we're just randomly selecting a sample size. Say we wanted a sample size of 50. Say that n was equal to 50. Okay, then we would just get that as our random sample size. Okay, example, I want a random sample of size n. Well, how could I get that? Well, I could place all names of the people in the classes in the class in a bowl and select 5 of them. Okay, I'm going to stop there at this point. Okay, the rest is for you to work through on your own. Okay, so look through the examples here. Okay, and continue on your own. Okay, and then once you work through these examples and the problems that are after this, then move on to 1.3 and 1.4, and I'll meet you in the next video.